Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ. I'll say easy MCQ. So you have to say what is the product of this monobromination reaction. What is the nature of the product? I'll say diastereomer, racemic mixture, mesoproduct, or constitutional isomer. I request everyone please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried, so let's do it. So actually, if you look at this, it's a hydrocarbon having an aromatic part, and its reaction with bromine and HNu. HNu means actually radiation which is responsible to break this Br-Br bond. Now if you look at these bromine molecule, actually both of the bromine atoms are octet filled and each bromine atom has 3 lone pair on itself. Actually this halogen, I mean here bromine bond is not that much stable. Why? Because this lone pair repulsion makes this bonds unstable. Similar kind of activity I guess you will observe in case of hydrogen peroxide, hydrazine, hydroxyl amine, etc. molecules. Now what happens? You are supplying HNu. HNu means energy. So that energy will help to break the bond homolytically. I repeat, homolytic cleavage to produce 2 bromine radical. So if you look at this 3 lone pair will be there as it is, but 1 single electron will be there. Previously each of these bromine were 8 electron species, but right now after this homolytic cleavage it is a 7 electron atom or species, you can say. Now from this point I can say these bromines octet is not filled. So it is electron deficient, and actually if I say it is very reactive. That is the reason it reacts with CH bond. Actually if you look at CD also, this deuterium is also an isotope of hydrogen. So chemically similar type you may consider. So that is the reason it can react with stable carbon hydrogen bond. Okay, so this is. Now if you look at here this arrow, I have given a half arrow. Why? This is called, student, fish hook arrow. The fish hook is used to catch fish. It is like that. This half arrow indicates the movement of single electron. Now let's see what happens here. So here bromine first converted in presence of HNu to Br radical. 2 Br radical, I am showing one. Here one benzene ring. So one benzylic position. Another is this deuterium hydrogen part, and finally there is a CH3. So technically if you say this molecule has many possible site for attack, site number 1, site number 2, site number 3, or in this benzene ring, so 4th option. Now among them this bromine radical will react with site number 3. Why? Because this bromine radical 7 electron species, so it will prefer to fulfill its octet. Okay, so what it will do, it will react with the proton of this any hydrogen, so 1 electron. So in this way it abstracted the proton and resulted HBr, hydrogen bromide. Now it is octet filled, stable. Now this bond, 1 electron went and formed bond with bromine, so there will be 1 electron remaining. So this is, by the way, these could be called as benzylic radical. Okay, remember student, benzylic carbocation, benzylic carbon ion, benzylic radical, all are resonance stabilized. I am not showing other part, just I am showing one resonance, that how this benzylic radical is stabilized. So 1 electron here, 1 electron there, 1 electron here. So in this way the first canonical form is associated with the radical at ortho position. By the way, this side is the substitution. Now similarly there 1 pi bond, so again radical will come to this para position. Again in the next canonical form the radical will go to this ortho position. So what is the conclusion? This radical is distributed in this benzene ring. By the way, radical means actually 7 electron species, means you can say this is nothing but electron deficiency. And since this electron deficiency is delocalized, so each carbon atom is having lesser electron deficiency, means this resonance or delocalization results Stabilization to some extent, I repeat student, radicals are not that much stable, but due to this delocalization it is to some extent stabilized. So that is the reason that this radical produced at the benzylic position, because the radical is stabilized due to resonance. Now here the radical is produced in the next phase. Next phase you can say, okay sir, elimination reaction to produce alkene. See student, I have already mentioned what is the product here. So here that is a very less chance elimination, rather than there is actually this bromine broke down this Br2 molecule and it has produced two bromine atom. So one consumed one hydrogen and produced HBr. There is one bromine remaining. So these bromine will be added to this. Now after this bromine addition, you can clearly see this center, this carbon is also chiral carbon, as it is attached with 1, 2, 3 and 4 different functional groups. But now what isomer will be produced? See, in this carbon I have clearly mentioned the 3D orientation of the groups. This methyl on the plane, hydrogen bottom, deuterium top. So this carbon is actually this center is enantiopure. But if you look at here, see, when this radical can come in conjugation with this benzene ring, when this radical is in the p orbital. So that p orbital come in conjugation with this benzene ring, with the p orbitals of this benzene ring. Now if I say it's a p orbital, then one thing is clear, okay? So it has two lobes. Now this whole p orbital is carrying one electron, but it has two lobes. Now this bromine can attach with the top lobe, or it can attach, by the way it should be half arrow, with the bottom lobe, any option possible. So if one side attack, if it result, means it will overall result a enantiomeric pair. What do I mean? Means both chiral centers. So one case maybe bromine is top, hydrogen down, so the other center will remain as it is, deuterium hydrogen. This is chiral, this is chiral. And another canonical form, it could be pH. Now in this case I will say that, okay, this neighboring side will be as it is, there will be no change, but here this bromine may get down, the hydrogen may come top, bromine get down. Okay, so these two isomer. Now in these two isomer you can see that one enantiomer or one chiral center is same for both cases. This one is same, there is a difference. So this center and these centers are mirror image, so the overall molecule is not mirror image to one and another. So what it is called? It is called diastereoisomer. By the way, sometime you may think, sir, I'm not able to understand how it could be mirror image. Remember one statement, single exchange changes the configuration, but double exchange doesn't change the configuration. I repeat, single exchange of these groups changes the configuration. So here bromine was in top, hydrogen bottom, here bromine bottom, hydrogen top. It's a single exchange, so it changes the configuration. So you may consider they are actually enantiomeric relationship. Okay, but this carbon is same for both sides, so that's why they are not mirror image isomer, so that's why they are actually diastereomers. Okay, so here you got your answer. Now if this question appeared in your exam less than 30 seconds, how can you solve it? Very easy. First, bromine H nu radical and this bromine radical will abstract proton here, because benzyl radical is more stable. Remember, radical or carbocation in both cases, means actually radical and carbocation case you observe more, it may be possible in carbon ion also. So since these intermediates are in conjugation with this phenyl ring, means the negative charge, positive charge or radical on the p orbital. P orbital has two lobe, equal probability. So okay, this side is fixed, here both isomer, diastereomer, only one option. And in this case I suggest please remember the definition, that is essential. Okay, so this is the overall discussion. I believe this video may be useful. Thanks for watching, and if you really enjoy the content, please help this channel to grow. And regarding any doubt about the logo of my channel, please read this part, your doubt will be clear. See you in my next video. Bye bye.